Jamb 2026 candidates, welcome to the continuation of our Jamb UTME preparatory lectures, okay? Destroying the Jamb Syllabus 2026. And we are continuing with the topic we have here, electrolysis, okay? But though we are starting with electrolyte because that's what Jamb wants from us, okay? Before we start, get your pen and your notebook to jot down whatever you understand in this lecture because you are definitely going to need it for subsequent revision. I know why I continue to emphasize on your getting your pen and your notebook to jot down. I know why they talk am. Don't be say if time don't reach, you go be like saying you dey lag behind. You can't be like who no get direction. I know how they be because many people they like rush. So that when that rush time reach, you yourself you go calm. Only what you are going to be doing is looking at your notebook, looking at all you've jotted down, looking at your past questions, doing exploration study. You will be calm. Exam done here, you go calm. Let's get into it. Electrolysis. Before we look at this electrolyte we have here, let's understand the concept of electrolysis. What is electrolysis? Let me ask you. What is electrolysis? You did like say you know book. You know book. Okay, what is electrolysis? Electrolysis can be defined as the chemical decomposition of a compound in a molten form, which is brought about by the passage of direct current. That is electrolysis. And a compound that conducts electricity and decomposes during the process is called what? Electrolyte. As easy as that is easy. Shikina. So electrolysis is a chemical phenomenon whereby a compound decomposes into its constituent ions, and that compound is in a molten form. When you say the compound is in a molten form, it means that the compound is not in a solid form and it's not in a liquid form. So it's like in a paste. You know how paste they be now? Semi-solid. It's in that molten form. It decomposes. And why does it decompose to various ions? Why does it release ions? Okay, the ions that makes up the compound. Why does it release that ion? It is brought about or it is induced by the passage of direct current. That's electrolysis. And such a compound that conducts electricity and decomposes in the process to yield ion or to release ions is known as this electrolyte that you see here. Easy peasy. Easy peasy. So what we have here on the screen, it reads electrolyte. Electrolyte is a substance that conducts electricity in molten or aqueous form due to the presence of free ion. So why is this substance capable of conducting this electricity and decomposing in the process? Because this compound has free ions. This is also the reason why metals conduct electricity. Because there are presence of free ions, mobile ions, ions that can easily be exchanged, ions that can easily be what? Exchanged. So, when this electrolyte conducts electricity in the molten form, because of the presence of free ions, they dissociate into what? I tell you say dissociation na scatter. Something just scatter. You'll be like say you dissociate my head, don't mean say you scatter my head. Eye go one side, nose go one side, ear go one side, mouth go one side. Just like that. So anytime you hear dissociation, just remember scatter. Scatter into its components, waiting former. You can see all those things way former, the small units way former. So it scatters into cations, which is positive ion, and anion, which is negative ion. So that's that for electrolysis and electrolyte. So what are the examples of electrolytes? The first example we have here is acid. For example, most acids are electrolytes because they are conductors and they also dissociate. They easily dissociate, ionize, and form. Yes, all strong acids are electrolytes. Acids are electrolytes. That's also the property of acids. Among properties of acid, okay? Acid are electrolytes. They conduct electricity because of the presence of what? Free ions, okay? They can ionize. And also basics, okay? Strong bases, strong alkali like caustic soda, sodium hydroxide, okay? Caustic soda is the common name. And salts are also electrolytes. Salt like sodium chloride is also electrolyte, okay? Salt like ammonium chloride is also electrolyte, okay? That salt ammonium chloride is an electrolyte present in a cell called Leclanche cell. That is the primary electrolyte in Leclanche cell. All right, if you are not taking my lecture on cell, please do well to take my lectures on battery cell. It's very short, concise, straight to the point, only what Jamb wants you to know. All right, let's look at non-electrolytes, okay? When you see non, just know that it's quasi, okay? It's away from the normal, okay? It's against. It does not have what the normal one has, or it does not do what the normal one does, okay? So when you say non-electrolytes, it means that it does not do what electrolyte does. It does not have what electrolyte has. All right, so let's look at what it is. It's a substance that does not conduct electricity, exactly what I explained to you, because they do not produce ion. No free ions. Example is sugar, alcohol. You see all those organic compounds, most of them, all those organic compounds, most organic compounds are not electrolytes. They can be used for electrolytes. Most organic compounds. Alcohol is ethanol. Pure water, all these, they are not electrolyte. But some water, like ionized water, can be electrolyte. That's why they indicated it here, pure water, okay? So ionized water can act as electrolyte, or brine, okay? Brine is an aqueous solution of sodium chloride, okay? When sodium chloride is dissolved in water, that's brine. That's aqueous solution you have when you dissolve sodium chloride, normal salt in water. That's called brine, okay? And you remember how chlorine is manufactured industrially? Industrial manufacture of chlorine, it is manufactured through the what? Electrolysis of brine for large scale manufacture of chlorine. Now let's look at the test. So what is the test of non-electrolyte? How do you know that a compound that was once an electrolyte is now a non-electrolyte? It's no longer conducting electricity and dissociating during the process or decomposing during the process. The test you use is you use a conductivity tester or observe bubbling in the what? In the electrolysis setup. When there is presence of bubbles in the electrolysis setup or in a cell, what is that called? What is that phenomenon called? The presence of hydrogen bubbles. That shows that the cell is damaging, right? It shows that the electrolytic component is damaging, right? That is called polarization. The presence of hydrogen bubbles in a cell. Okay, that is polarization. The presence of what? Hydrogen bubbles in a cell is known as polarization. So that shows that what used to be a conductor or what used to be an electrolyte is no longer an electrolyte, or what used to be an electrolyte has been replaced or has been significantly replaced by a non-electrolyte. Moving on. Now, we want to look at the king, the Odogu of electrolysis. His name is Faraday. He's such a great man. Almost everyone studying physics knows this man. Okay, if you have done anything related, see this man, his name too appear for physics. His name appear for physics. For electricity, his name commands. Okay, for electrolysis, his name commands. Anything electro, this man name did. Even for gravity, gravitational law, Faraday is also there. You see, so Faraday is a king. He's an Odogu in physics. That's why you have to draw closer to Faraday. Draw closer to Faraday. Faraday sabi plenty things. He sabi plenty things. He postulated a lot in physics. Okay. Now let's look at his first law of electrolysis. Very easy. Very easy. I am going to explain all the laws of Faraday pertaining to electrolysis for you. The first law of electrolysis is the masses of an element discharged during electrolysis is directly proportional to the amount of current passing through the system. What he's saying is that the current passing through the system is equal to the mass of the element discharged. That ion, the mass of that ion, ion of the element discharged during the electrolysis is equal to the amount of current you put in the system, you pass in the system. If you pass 2 ampere, for example, in the electrolytic system, that's the current you pass in the electrolytic system. The mass of the element that is going to be discharged will be what? The same, which is what? 2 kilograms. For example, if it is 5 kilograms of the element that is discharged during the electrolysis, it shows that you have passed 5 ampere. Okay, so the mass of the element discharge is equal to the what? Is directly proportional. It's equal to the current, but passing through the system. So that mass that we are talking about is the quantity. Okay, quantity, or you can represent it as M. All right, M, because the mass, quantity of element, quantity. That's this Q that you are seeing here. This is the formula. The quantity or the mass is equal to current times what? Time. Where I is current and T is what? The time taking. Easy. So if you want to use this first Faraday formula to solve, how are you going to know if you are supposed to use the first Faraday law to solve a question from electrolysis, or you are going to use the second Faraday? It's through the parameters given. If you look at your question, the parameter given is current and time. Now this one you go use now. You go to use another one with current and time no day or we no complete. Now this one you go use the first law. If you look at it and you don't have current and time inside, you use the second law. The second law. We are going to discuss the second law very soon. Remember what I always say about making of subject formula. It is not all the time, Jamb, we ask you that what is the mass of the substance discharged. Though it's very common. What is the mass of element discharged? The mass of aluminium discharged? The mass of gold discharged? The mass of copper discharged during so electrolysis? Yes, then they ask well like that. And we are going to treat that calculation. It's very easy, trust me. But they can also ask you what is the time taking for so mass of element to discharge when so current was passed. So they gave you mass, which is this quantity, and they gave you current, which is this I. What do you have to do? You have to make T the subject of the formula because you're looking for time. If you carry T come here, you are now going to be left with I over what? Q. So when you do I over Q, you substitute your parameters into the formula. You do I over Q, you get your answer Shikina. They can give you the quantity of mass, which is the quantity of mass, and they will also give you time. They will ask you what is the current required. You also do the subject of the formula T. So if you make I the subject of the formula, you are now going to be left with T over Q. I is equal to T over Q. As easy as that, basic mathematics. That's what you need. Foundational knowledge. I always emphasize on this foundational knowledge. That's what you need. Jamb is very overrated. I tell you. I've been doing this for almost 4 years now. Jamb is very overrated. I know why I tell you. I will say I see teacher will be like me during the time where I take Jamb. I would have scored nothing less than 360 in Jamb UTME. I know, no lies. No lies. Now, let's look at the Faraday second law of electrolysis. The Faraday second law of electrolysis states that when the same quantity of electricity is passed in different electrolytes, the same quantity of electricity passed in different electrolytes, the charge on them, that's the charge for the electrolyte, is proportional to what? Their equivalent masses. Now, we're going to talk about charge now. When the same what? Quantity of electricity is passed in different electrolytes, the what? The charge on them, their charges, is directly proportional to what? The equivalent masses. The equivalent masses. So when you say the equivalent masses, when you don't add all their masses together, okay, all their masses, which is their molar mass, when you don't add all their masses together, the charge on them is equivalent to it. So when person tell you, when they tell you say the charge on them is equivalent to it, when they ask you say the masses of elements liberated during when so thing, that one will tell you say you will find the molar mass of the complete compound, which is the equivalent masses. That's what you are going to use to get the charge of it. Then you use your Faraday to get your answer. You divide both sides with your Faraday. Now, if we should read what we have here, it reads masses of different substances liberated by the same charge are proportional to their equivalent masses. So it's the same thing, but I'm giving you a simpler, simpler statement of the law. Okay, I said when the same quantity of electricity is passed in different electrolytes, their charges, okay, the charges on them is directly proportional to the equivalence of their masses. Okay, so the equivalence of their masses, remember, different electrolytes. The first law is talking about one electrolyte. The second law now is talking about different electrolytes. You are passing the same current in different electrolytes. So in a question where you have more than one electrolyte, that's telling you that is this formula that you are likely going to use. Okay, this formula of the second law. And the relation is given by mass, which is M, is equal to what? Z times Q, where Z is the what? Electrochemical equivalence. Z is the what? Electrochemical equivalence. So remember the making of subject formula thing I talked about. I always emphasize on it because Jamb are very awkward sometimes. They will know this formula, but they will carry this one, they will give you this one, they will tell you, say, maybe you find another thing. If you can't think that I have so thing inside the second law of Faraday formula, you will not be able to answer that question. You will see them as hard question, but it's not hard. It's very easy. Now, the constant of this second law of Faraday is the Faraday constant. 1 farad is the constant, and 1 farad is equivalent to what? 96,500 coulomb per mole. 96,500 coulomb per mole. This is the Faraday constant. Okay, you use this constant to solve per mole. Okay, use this constant to solve. And you know coulomb now. What is coulomb? Coulomb is the SI unit of quantity of charge. Okay, or charge. Okay, remember that the second law of Faraday is talking about charge. All right, so he's talking about charge. He said the charges on them, okay, on the electrolyte is directly proportional to the what? The equivalent of their masses or their equivalent masses. Okay, so this Faraday constant 96,500 coulomb per mole is equal to charge of 1 mole of what? Electrons, which is what? 6.02. This one is Avogadro's constant. 6.02 times 10 raised to the power 23. Okay, so this one, all of them for here, they are proportional to each other. All of them are proportional to each other depending on what you are giving. They might give you this one, you are going to use it as constant. If they give you 1 Faraday, you are still going to use it as constant. If they give you 96,500, you are still going to use it as constant. Okay, just know that this one 6.02 times 10 raised to the power 23 Avogadro's constant. Okay, 1 mole of electron is also equivalent to this 96,500 coulomb per mole. Okay, but this one is in electrons. Okay, here you are calculating in electrons. Okay, here now when they ask you question related to electrons, now you will use this one, this Faraday constant 6.02 times 10 raised to the power 23. But when you are asked to calculate in quantity of charge, coulomb, okay, coulomb per per mole, you go use this one. But if they ask you say when you calculate the charge, not the quantity of charge, you are calculating charge, you use Avogadro's constant. Now let's look at the Jamb calculation question style. How Jamb will take the set calculation question for you for this particular topic. Now we want to look so the kind of question where Jamb will set for you for April. Now they will say calculate mole of electrons on mass deposited. This one another style, moles of electrons on mass deposited. For example, they will say if 2 Faraday, you already know what 1 Faraday is equivalent to. And remember that 1 Faraday is equivalent to Avogadro's constant in electrons when you are talking about electrons. And you can see moles of electrons or mass here. They ask in different ways. They can either ask you moles of electrons where you are going to use the Faraday constant, or they ask you mass. If they ask you mass, you go use weight Faraday constant. If 2 Faraday of charge deposits 1 mole of metal, find mass using atomic mass. We are going to have a lecture on that. Just no worry, no just worry yourself. Now let's look at electrolysis of specific solutions, especially the common ones that Jamb specify that they say make you know, make you put them inside your head. Okay, electrolysis involves passing electricity through an electrolyte, causing ions to discharge at electrode. Okay, and there are 2 types of electrode in electrolysis. Okay, you have the anode, which is the what? The positively charged electrode or the positive electrode, and you have the cathode, which is what? The negative electrode. Okay, or the negatively charged electrode. The anode is the site of oxidation. Oxidation takes place in the anode. In electrolysis, so in electrochemical series, it is different to it is different. The position of charges on electrode is different in electrochemical series. It's opposite of what you have in electrolysis. So in electrolysis, you have anode as the positive electrode and you have cathode as the negative electrode. But in electrochemical series, you have this anode as negative there. Then you have cathode as positive. You can see that it's opposite. So when you are dealing with electrolysis, anode is positively charged electrode, while cathode is negative. But when you are dealing with electrochemicals, okay, anode is negatively charged, while cathode is positively charged. Always remember that oxidation occurs in where the anode in electrolysis, while in the cathode reduction occurs. Remember, this electrolyte dissociates. So for it to dissociate and release its ion, redox must occur. There must be oxidation and there must also be reduction. Okay, so that oxidation occurs in the anode and reduction occurs in the cathode, which is what cathode is the negative electrode. Look at this statement here. It reads, use inert electrodes, for example, platinum, unless specified. So this is telling us that during electrolysis, it is good to use inert electrode. Okay, when you say an electrode is inert, is that the electrode is stable. Electrode, what is an electrode? An electrode is a substance. Most of the time, now metal they always be, but sometimes there are also non-metals that can also serve as electrode. Okay, like carbon, okay, graphite. Okay, but most times electrodes are metal. They conduct electricity. So electrode is a conductor. Okay, it's a conductor. That's what an electrode is. A conductor used in electrolysis. It can either be used as a positive conductor or a negative conductor. Okay, in electrolysis. So it's telling us that we should use inert electrode such as platinum. When you say something is inert, it means that that thing is stable. It does not easily react with something. Not the electrode where you go put for the system now. The electrode itself will react, because that's the problem we face with electrodes that are not inert. That's a reactive electrode. Okay, unstable electrode. When you put them, the electrode is going to start reacting. Okay, with the electrolyte or with the components of the electrolyte itself. But when you use an inert electrode, the electrode is going to remain like a catalyst, just like the way you harvest catalyst after chemical reaction. You know, catalyst doesn't change during chemical reaction. Okay, after the reaction, you can recover the catalyst. That's how you are going to recover this electrode. It's going to be there, nothing good one. But if it's unstable electrode, you go change electrode tire. Electrode will just be burning out. That's going to lead to loss of electrode, which is going to make the process expensive. But it says use inert electrode such as platinum so that it will not alter the system, the electrolytic system, and you are not going to have depleted electrode. Unless specified, because there are some electrolytic process that demands the use of certain electrode. Okay, it has its own specified electrode, use also electrode, like the ones that we are going to treat now. The first we have here is electrolysis of dilute tetraoxosulfate 6 acid with inert electrode. So this one is with inert electrode. If you go and use electrode that is unstable, it is going to bond. This is a strong acid. It's going to attack the electrode and it react with the electrode to form another compound. So it's going to affect the electrolytic system. So what we wanted to achieve through electrolysis, we feel no come achieve at begin. So as the cathode, which is what? Negatively charged electrode, what happens there? Reduction happens there. Okay? And what happens during reduction? Is reduction loss of electron or gain of electron? Reduction is electron gain. You can see that hydrogen gained 2 electrons here to form what? Hydrogen gas. Okay? Reduction occurred here. Okay? While in the anode, what happened there? Anode is what? Positively charged electrode. What happened there? Remember, we use inert electrode. Inert electrode can be what? Platinum. It can be gold. It's just any electrode that is what? That is non-reactive, that is stable. In the anode, which is the what? The positively charged electrode, what happens there? Oxidation happens in the anode. And oxidation is what? Electron loss. So water loses 2 electrons to form what? Oxygen. Okay? Water loses 2 electrons. It loses this hydrogen. Okay? 2 molecules of hydrogen to form what? Oxygen. Alright. So what are the products gotten during the electrolysis of this hydrogen tetrasulfate 6? Dilute hydrogen tetrasulfate 6. What are the products gotten? The products gotten are hydrogen gas at the cathode and oxygen at the what? Anode. As simple as that, chicken. You can see the elements discharge in the cathode, hydrogen gas. While in the anode, what waiting come out for the anode? Oxygen. During oxidation, then oxygen can discharge for the anode. Note, water is oxidized over sulfate ion. So instead of sulfate ion to undergo the oxidation for the anode, now water now undergo that oxidation to yield what? Oxygen gas. What if Jamb can't give you question where they say you don't know of that electrolysis before, or you don't remember waiting discharge during the electrolysis? Though it's very easy to know, because all you have to do is to write out the chemical reaction. Okay, just like you are seeing it here. You already know that oxidation occurs in where? In the anode. Reduction occurs where? In the cathode. You write the oxidation reaction for the anode. You get waiting will come out for there. Waiting will discharge during the oxidation. Then you write the reduction for the what? The cathode. You get waiting will come out for there. That's it. If you have not taken my lecture on oxidation and reduction, please go and take it to. It's in the playlist. No go lose guard. Jamb, they always set question, and you can see that oxidation and reduction, the knowledge now applies to what we are doing here now. It applies here. So please go and take my lecture on oxidation and reduction. So that's it. So Jamb always ask what was discharged in the cathode and what was discharged in the anode. They ask that question. But I will give you one easy way where you go take easily, just quickly get waiting discharge for anode and waiting discharge for cathode. Okay, for inside example, without stressing yourself, you can write the equation for oxidation for anode and reduction for cathode. We are basing on this principle, the charge principle, electric principle. Like charge repair, unlike charge attracts. Listen to me. Like charge repair, unlike charge attracts. So like charge, just see like charge as man marry man or woman marry woman, homosexuality and lesbianism. You know, say the society hate them. If man see man, man know they want the follow man they do. So they are like, you understand? They are like man. They repair each other. No touch me, no near me. Like charge, they repair each other. But unlike charge, they attract each other. They do what? They attract each other. So if I be male, you be female, we will attract each other because it's normal. So how does this explanation apply here? The discharge of elements. Okay, make I teach you. You have to know the ion, okay, the charge on the elements. For example, oxygen is a non-metal, and non-metals are mostly what? Negatively charged. Most non-metal are in fact, all non-metal are negatively charged apart from hydrogen, which is positively charged. That's the only exception. It's a non-metal and it's positively charged. But the rest are negatively charged. So what does that tell you when it comes to the electrode? Since oxygen is negatively charged, what charge or what electrode, what charge of electrode will it be attracted to? You got it right. It's going to be attracted to the what? The positively charged electrode. And what is the positively charged electrode? The positively charged electrode is what? Is anode. And that's what you are seeing here. That's why you're seeing oxygen will be discharged. So the oxygen will be attracted, the negatively charged ions will be attracted towards the what? The positively charged electrode. While the positively charged ions or the positively charged elements, okay, elements with positive charge, will be attracted to where? The cathode, the opposite charge, the negative charge. So it only happens rarely, and Jamb don't set all those kind of questions, okay? It only happens rarely where you will see a positive electrode having positive elements discharging from there. It is very rare. You know, too common. It's very rare. Okay. So hydrogen is a non-metal, but it's a positively charged element. So that is going to force it to go where? It's going to be attracted towards where? The negatively charged electrode. Okay, or the negative electrode, which is what? Cathode. That's why it's charged. So you don't even have to be writing oxidation and reduction equation up and down. All you need to do, just use this simple principle I just gave you, and you can easily know which element discharge from anywhere among the options. So you go need to look the electrolytes, the electrolyte that underwent electrolysis, so that we know the constituents that should come out. So as we don't look this one, we don't already know say oxygen will likely come out. Okay, for this one, hydrogen will likely come out, water will likely come out, depending on what they give you for option. And most of the time, now elements they discharge, no be compound they discharge. Now elements they discharge. It is either oxygen come out, sulfur come out, or hydrogen come out. So depending on what you have in the option, then you use the like charge repair or like charge attract. Use that principle to, you know, bomb, come on there. Within 10 seconds, you don't answer Jamb UTME question. So the second one that we are looking at is electrolysis of aqueous copper 2 tetraoxosulfate 6. Okay. In this electrolysis, we are using what? Copper electrode. So copper electrode is used. Remember, the first one was inert electrode. Okay. So this one, copper electrode, is suitable for this electrolysis of aqueous copper 2 tetraoxosulfate 6. And this aqueous copper 2 tetraoxosulfate 6, aqueous means that copper 2 tetraoxosulfate 6 was dissolved in water to form a paste, making it what? Molten. Okay. Remember, during electrolysis, the compound or the electrolyte has to be in the molten form. Okay. And in the cathode, what happens there? Remember what cathode B? You know what in cathode B? So we have to be faster. Reduction happens there in the cathode, and copper 2 ion is reduced to what? Reduction is what? Is electron gain. Copper gains 2 ion to what? To form copper what? Copper metal. Okay. And copper metal is deposited in one of the electrodes. Okay. And you suppose don't know the electrode where this copper will be, because you know the charge where you say copper get as a metal. I don't need to talk too much. So in the anode, oxidation occurs there, and what? Oxidation is what? Electron loss. So copper metal loses electron. It loses 2 electrons to form what? Copper ion. Okay. Copper ion. So copper ion dissolves. That's why you are seeing dissolution. It dissolves in the what? In aqueous solution. It dissolves in the aqueous solution. So during this electrolytic process, this anode is lost. Remember what I tell you about when you use an unstable electrode. It's going to be depleted. The thing will join the process. It will chop the electrode, chop the electrode will finish. You will change the electrode tire because it's what? It's unstable. It will join the reaction. So that's what occurred here. So this copper ion dissolved. Okay, it dissolved. It dissolved in the electrolyte. You are not going to get it. It's going to deplete and it will finish. So the product gotten from electrolysis of aqueous copper 2 tetraoxosulfate 6 is copper. Copper is deposited at the where? Copper is what? Positively charged what? Electrode. So where you expect them to discharge, which electrode will attract positively charged electrode? Is it not the negatively charged electrode? And that's cathode. While the anode, and copper ion supposed to be there, but it don't dissolve. What is it used for? It is used for the purification of what? Copper. Then no say now this copper electrode will be the most suitable for this purification of copper, the electrolytic process involving the purification of what? Copper. Now make the user, because if you use an inert electrode, you are not going to be able to purify this metal. Okay, so you can see that it depletes with that ore, that impurity where they the metal, where they the copper metal. Now they join the you know, this copper ion, they deplete. While we get our, you know, our sharp copper metal, lustrous copper metal for here. Okay, for the cathode. Now let's look at others. I'm going to be faster. This is the electrolysis of aqueous copper chloride. And what was used? Inert electrode was used, and in the cathode, reduction occurred there. Copper gained 2 electrons to form what? Copper metal. Okay, copper metal is discharged when it gains 2 electrons. And in the anode, what happens? Chlorine loses 2 electrons to form what? Chlorine gas. Okay, chlorine is discharged. What products were formed, or what product is formed from the electrolysis of copper chloride? You get copper metal at the cathode, then you get chlorine gas at the anode. Now, electrolysis of dilute sodium chloride solution with inert electrode. In the cathode, reduction occurs, and hydrogen gains 2 electrons to form what? Hydrogen gas. Okay, hydrogen ions from water, okay, gains 2 electrons to form hydrogen gas. While in the anode, chlorine loses 2 electrons, oxidation occurs here. Chlorine loses 2 electrons to form chlorine gas. Okay, and what are the products formed? Hydrogen gas at the cathode, then chlorine gas at the anode. Electrolysis of concentrated sodium chloride solution with inert electrode. Okay, at the cathode, reduction occurs, and hydrogen ion accepts 2 electrons to what? To form hydrogen gas through reduction process. And in the anode, what happens there? Okay, chlorine loses 2 electrons to form chlorine gas, or hydroxide loses what? 4 electrons to form oxygen and 2 moles of water. This happens if the concentration is very high. So the concentration is, if it's very high, this is going to happen in the anode. Okay, instead of chlorine to lose 2 electrons to form chlorine gas, hydroxide ion loses 4 electrons to form 1 mole of oxygen gas and 2 moles of water, if very concentrated. So the products formed are similar to dilute but check concentration. Okay, the concentration here is slightly different. The concentration of the products formed, the metals, the metal discharge and the hydrogen gas discharge is the same, but the concentration differs. Okay, because of the high concentration. So for the dilute, what will we get? We get hydrogen and chlorine. Okay, so let's look at the electrolysis of fused sodium chloride. So Jamb, same way we make sure we be familiar with all this electrolysis. So in a molten form, no water. It's in a molten form, but we don't add water. It's fused sodium chloride. So the paste should be thicker. So at the cathode, reduction occurs, and sodium accepts 1 electron to form sodium metal. Okay, there at the anode, oxidation occurs there, and chlorine loses 2 electrons to form chlorine gas. Okay, 2 electron loss. And what are the products formed? Sodium metal at the cathode, then chlorine metal at the anode. Now let's look at the factors affecting discharge of ion. What are the factors that affect the ions that are going to be discharged? What are the factors? The first is the position in the electrochemical series. The higher an element or a compound or an ion is in the electrochemical series, that determines the extent of discharge of that metallic ion. For example, more reactive ions such as potassium. You know, say now potassium will be the first for electrochemical series. That's why you have to get familiar with the electrochemical series. So get familiar with the electrochemical series, okay? So more reactive ions such as potassium ion discharge later, less reactive discharge earlier. So more reactive ions, like the ones higher up, okay, the ions higher up the electrochemical series, discharge later, but less reactive ones, now they come out. People will not get level, all the ones will not get level. Any small quacker, they don't discharge. So what this means is that ions, metallic ions, or the ions higher up the electrochemical series, discharge later than the ones lower. So if you have potassium and sodium in the same system, in the same electrolytic system, sodium will discharge before potassium because potassium is higher than sodium in the electrochemical series. All right, but this happens significantly when the space between them, okay, the space where one take past the other man is very, very significant. Okay, if it's very, very significant, it could just show where saying that this one will fair discharge. Like this one now, this thing you have here. What is this element called? Silver. Okay, silver. When you have silver and sodium in the same electrolytic system, now once that silver will take move now because silver they down for the electrochemical series. All those ones don't get level at all. They don't get level. Silver, gold. The second is the concentration. The concentration of the the electrolyte affects ion discharge too. Okay, so the higher the concentration, the higher the discharge. So higher concentration favors discharge. The third is the nature of the electrode. Is the electrode inert? Is the electrode reactive? Or is the electrode unstable electrode? If you have an inert electrode, what happens? The electrode is going to stay and elements are going to be discharged. It's going to favor the charge. But when you have a reactive electrode, it's going to affect discharge. Okay, because the electrode is going to wear out. Okay, the electrode is going to wear out. For example, you can see how copper anode dissolved during the purification of copper, where we did the electrolysis of copper 2 tetrasulfate 6. So the copper anode wears off. Okay, so it affects discharge. So inert electrodes are better. So inert electrodes favor discharge more than reactive electrodes. So the over voltage, remember the Faraday law, the voltage, the amount of electric current to pass through the system is equal to the mass of element discharge. So that's it. Extra voltage needed for gas evolution. So if it's an electrolytic process that you involve gas is going to be likely discharged you need a higher voltage to facilitate that, okay? But higher voltage also favors ionic discharge during electrolysis.